So this is going to be a week 5 assignment. So first I'm going to do is I'm going to go ahead and clear, I already cleared all the ammunition off my work desk. We're going to go ahead and clear the rifle. So we're going to go ahead and look, feel, nothing's there, so we're clear, good to work. So to start with, for part 1 of assignment 5, we're going to go ahead and perform a functions check. So functions check, basically we're going to go through the firing process to see if everything works. So first of all is now the weapon all safe, squeeze the trigger, nothing should happen. Okay. Second part of this is going to be put the weapon on fire, squeeze the trigger, it should fire. Now, we should fire, we should be able to rack it back, and it should be able to recycle and reset the hammer. So, it's reset. Once we release the trigger, we're going to hear an audible click. That's resetting the trigger. Now we're going to go ahead and squeeze. We should be able to fire again. Okay, so so far that's a good functions check. Everything is operational and it works. So now we're going to go ahead and move into quickly a functions check with dummy rounds. So I've already had my magazine preloaded with dummy rounds. So we're going to load the source of ammunition from here. Doing a function check is we're going to make sure the cycle operations is working properly. So the first part is obviously putting ammunition, which is feeding. The first part of feeding is going to be chambering. So when we chamber, we're going to go ahead and pull the bolt back to the rear. Doing that, it's going to go ahead and go in through chambering, which is going to grab a bolt around, push it into the chamber, just like that. Going to go into the locking phase. So once we go to the locking phase, we should be able to go ahead and push the weapon on fire. Okay, squeeze the trigger and it should click. So the weapon then would have fired. The gases would have come back to the gas tube, come back into the actual bolt, pushed or forced the buffer string and the buffer back, going into the extraction phase. So that's going to go into. The bolt's going to come back. The actual bolt face is going to grab onto the round, pull it out, cause extraction. And then we're going to go back into feeding, which is going to be where the round comes back up and feeds another round. So based on my observations here, everything is running normally with a dry functions check. So that's the actual good part. Now, let's say we were to squeeze the trigger, nothing would happen. There's an issue with the trigger. If we were trying to pull this back and it wouldn't come back, there's a problem probably with the bolt or something in here that's not moving properly. If we pull the actual bolt back and it doesn't eject, now we have a problem with the ejector. So those are the kind of things you're looking for in a dry one. So once we go into live fire, then we're going to ensure that we have no short strokes, we don't have double feeds, we don't have stovepipes, and we have a nice flow of cycle of operation. Everything is properly functionally running smooth. There's no interruptions, there's no lags, there's no delay in the resets, there's no delay in the buffer. So that's what we'll be looking at for a live fired test. So I'm gonna kind of break this down, move into part 2. I'll be back. Okay, so I'll go ahead and take out the compensator, have it mounted up, and as guidance from the SDI book, we're gonna go ahead and measure the length of our barrel by inserting this rod. Go ahead and insert it here. So we actually hit the actual bolt. So I'll go ahead and mark. And I'll be right back. Okay, so we have the measuring here. We're going to go to the inside of the mark, so it's about 18 and a quarter. So my barrel measures 18 inches, 0.25. Okay, so now we're going to measure the twist rate of my rifle. So we're going to go ahead and stick this part into the barrel. So I'm about right there where I get some resistance. So I'm going to mark here. We're going to go ahead and push. I have a little tab on the end of here, which you'll see here shortly, and wait till it goes 180 degrees. So that's about 180 for me here. I'm going to go ahead and mark. Okay, and I'll be right back. Okay, so now we got it measured out. So start point is here, end point is here, which gives us 10. So for every one full rotation, it's a 1 in 10. Okay, so I'm back. So we measured the length of the rifle, we measured the twist rate. So now we're going to make sure that headspace and timing is correct for this 308. SDI has provided me with an awesome tool, which are actual gauges. So these are go and no-go gauges, which once inserted into the chamber, it will tell me if headspace and timing is correct, or there's any damages inside the bolt, on the bolt face, on the bolt itself, or even in the chamber or the breech. Okay. There's other methods to test this, but this is the easiest way. So right now we're gonna go ahead and test we'll go with the no-go gauge. Okay, so when testing this, you're gonna go ahead, and the weapon's already been clear. We're gonna go ahead, insert the no-go gauge into the chamber. It's gonna be flooded, seated flush. Now, when we do this, the actual bolt and the bolt kit and the charging handle should sit flush. So the charging handle is flush, but the bolt will not go. No matter how much I try, the bolt will not go because it's out of battery. It is not within headspace and timing. So in order to make sure that that's not check that is now we have the go gauge. So we insert the go gauge. It's in. We're gonna go ahead and try to seat everything forward. As you can see there, everything is flush and good to go. So that means that the rifle is in good headspace and timing. Now, if we do this, it should be able to come back without any issues. As you can see, it came out. The go gauge kind of flew out there, but we're good to go on headspace and timing. Okay, so now what we're going to do is we're going to measure the firing pin protrusion using the micrometer. I have my micrometer here. I have my actual firing protrusion kit here. Okay, so we're going to measure the entire thing as a whole. I'm going to go ahead and do the measurements and then I'll come back. Okay, sir, so I got the measurement, which is 0.6290. Now we're going to go ahead and measure the actual protrusion of the firing pin. So I have the firing pin here. I'm going to go ahead and push that in using this open space here. We're going to push down and we're going to lock this in place. Okay, now we're going to go ahead and measure this. So let me get the measurements and I'll come back. Okay, so after all the measurements and everything done, I ended up with a 0.041, which is still in tolerance for the AR-10. It's brand new, so it's still in. I haven't shot it, so there's no reason why it should be out of tolerance within the firing recess. So going back to I haven't discussed part 2, which is assessing the trigger. So for me, this is a stock trigger, and it's pretty stock. So it has again, we're gonna clear it. It's empty, nothing. For me, this is stock trigger, so it has a long time for a reset. So if we go ahead and fire, and we count 1001, or sorry, we go 1001, 1002, kind of 1003, kind of a reset, which is, I mean, it's standard. But for me, I'm going to replace the trigger, and I'm going to go ahead and put maybe like a 2-pound trigger, which would give me a really quick reset. So as soon as I barely inch off, reset. And that's what I'm looking for, to fire faster and be quicker. So that wraps up week 5, sir. Hope you like it.